Yeah, hi everybody. Uh, Hopefully this will not be interrupted as I'm at home and I'm trying to finish up the lab. And I'll have some announcements about lab for next week, and I'll try to provide you with some additional recordings so we can get all caught up. Uh, Effectively, this is the end of digestive. It's just a little bit of anatomy for the small and large intestine, and then we're done. That was yesterday's unit. So I'll have to provide you with the kidney information, the urinary tract information, which is relevant, and then male and female reproductive. So that's what's left for us to cover in this term, and I'm sure we'll get everything in without much difficulty. So this is PowerPoint C of 22, which you certainly have. I sent an email just to remind you that I'm putting these on. I think it says week 4, where you'll find these for respiratory, digestive, urinary, etc. So the small intestine. The numbers are misleading here. Not so much the diameter, so it's an inch or so, maybe a little bit bigger. The big number here that I think, I keep hitting the wrong button, that's misleading is this, the length. As you see, it's closer to 20 feet. I'd say 16 to 20 feet is a much more accurate representation from its start at the pyloric sphincter to the ileocecal valve. The duodenum, very short, less than an inch, wraps around, as you saw it before, the head of the pancreas. And they all have effectively the same feature, so it's not a distinction. There's not a significant difference between duodenum and jejunum. The jejunum is about, as you can see, the measurements 8 feet long, ileum 12 feet long, so that's a good 20 feet or so, as you can see here. And so, and interestingly, most of the digestive and absorptive activity really occurs in these first 2 sections. The ileum is, fine tuning it, taking care of what's ever left, getting everything ready to go into the large intestine, so to speak. You can see it color, this purple, blue, and reddish area. They're all nicely compacted because of the mesentery naturally. They arrange themselves. You don't have to do anything with it. When they're removed surgically, or when you lift them out to operate on an area, let's say on a kidney underneath it, they just go back in naturally. It's very interesting how that occurs. That's all because of the natural folds of the mesentery. Sometimes they telescope when there's problems associated with them. That's called intusception. It sounds like interception in football, but T-U-S-C-E-P-T-I-O-N, intusception. And there's that illustration you saw before, which you'll see again on the labeling exercises, I'm sure. So mostly a superior and for the small and inferior to the large. There's a little bit of overlap. And again, the venous drainage goes by way of the liver. That's that hepatic portal vein. And again, parasympathetic, mostly active, sympathetic, only in fight or flight, where it really shuts down activity more or less, minimalizes it. Okay. It's all about this. The surface area, if you stretch it out, like I commented on before, tennis court, for something that's basically a 20-foot long garden hose. These are the modifications. Circular folds, sometimes called plica, which means folds, circularis, which means circular, villi, fingers, and microvilli, tiny fingers. And so the circular folds, so the chyme doesn't shoot straight through as though you would put water into a tube or in a straw. A liquid would go through a straw. It circles around. There are little grooves and indentation. So it spirals around. The way you see some of those, like these have one at the science center, you put a quarter and watch it spiral all the way around. Okay. And so it facilitates time. It's about a centimeter deep, which is maybe, centimeters less than half an inch. Villi, which are finger-like projections, tiny, like little studs, nubs. And inside they have this unique apparatus called, this lymphatic capillary called the lacteal, surrounded by a capillary bed. That is where the materials are effectively absorbed, either directly in the bloodstream or into the lymph. And then microvilli, which is a brush border. It's these little protrusions that are all about surface area, and they have enzymes in them for that final step to break something down from a dipeptide to a single amino acid, a disaccharide like lactose into glucose and galactose, simple sugars. And then eventually, when they're absorbed, they're all converted pretty much to glucose. The interesting thing is that enzyme, the enzyme so famous as lactase, is missing for people who are lactose intolerant. Pretty much we're all born that way, but we develop it within X amount of time, and that's when you can make the transition from formula, which is typically not cow's milk, okay, to being able to drink cow's milk. And that's why cow's milk troubles a lot. Well, we don't typically have it in formula, if you're wondering. See, it's a pretty good construct. You can see how stuff will basically, oops, without me doing it, spiral around and around. A lot of blood vessels, the same circular and longitudinal muscles, no obliques. And here are these tiny little nubs that you can just make out here. And then when you'll do a close-up of the nub, which they do here, now each of these nubs has, this is the lacteal, the lymphatic in green, that's the lacteal in the capillary bed. And here you can see all of those cells. There's the simple columnar cells, the blue are the goblet cells. And each of those, and if you look at an individual cell, take a little cut out of an individual cell, it's just covered in microvilli. That makes the brush border. And this is what it looks like microscopically. You can see the lacteal. They're called them enterocytes. That's the name of the cell, the ones that have the brush border, because they're absorbing. And this is what it looks like, the microvilli. It's extraordinary, and it's all about surface area. So you only need really a couple of feet of this, and you can basically digest and absorb almost anything. Rather than pits, they have crypts that are scattered, not quite as abundant, let's say, as in the stomach. And they're mostly enterocytes that are there, the simple columnar cells. Okay, nutrients and electrolytes. The crypts are where they generate in an exocrine, secreting into the lumen, this watery mixture of mucus with a certain amount of alkalinity, bicarbonate in it. You also have the enteroendocrine cells. In physiology, you'll learn that these are the two primary hormonal substances. Cholecystokinase, which triggers the gallbladder, and it's cholecysto is what when we refer to the gallbladder. Cholecystokinase activates the gallbladder, or in its absence, the liver, to push out bile, and does other things. And secretin, which is the principal hormone that acts on the small intestine to make all of these wonderful digestive enzymes and fluids and things like that. The crypts are interesting because they're the most sensitive to chemotherapy, and they're the most sensitive to radiation therapy. They go fast. That's why diarrhea and malabsorption and problems, gastrointestinal problems, are so abundant in people undergoing like cancer chemotherapy or radiation therapy. And then there's panacels, or antimicrobials and stem cells. And you can see they're reproduced every couple of days. There's always going to be these little aggregates called Peyer's patches of these little nodules. And again, in that underlayer underneath the lining, in that lamina propria, as you go farther along, more of it, because you have more potential invaders that effectively can colonize that area. The bacteria increase, so we have more Peyer's patches, if necessary, if they're harmful, to deal with them. And you have a variety of other glands. You can see alkaline mucus, etc. This is the chemotherapy nugget. As you can see, I'm listening for the dog in case he does anything. And again, the big deal that makes this system go is stretching or various kinds of irritation, along with pH. The acidic chyme will trigger its response to neutralize it with the bicarbonate or alkaline fluids, and hypertonicity, highly concentrated area. So effectively, the juices are alkaline and become isotonic with the blood plasma, as you can see. And again, now it's 3 to 6 hours. It takes a while for stuff to completely digest and absorb. So as you can see, bile, bicarbonate, digestive enzymes, don't know what the dog's doing, and not the brush border enzymes. Those are inherently part, that final phase of absorption, but everything else comes from either the pancreas or the liver that are there. And again, little squirts of chyme come in to avoid it being problematic. This is where we start to really see segmentation. There's something called an intrinsic pacemaker cell that governs it and moves it. Okay, and along with the reflexes, the long, which are the parasympathetic and sympathetic, and the short, which are the enteric system. And that's worried about migrating motor complexes. But you can see from the duodenum, at least 2 hours for just the stuff to start to go through. They're showing you the picture we saw before, and a variety of reflexes that control passage of food, and basically alerting the next level that stuff's moving in, so we have to be ready to move stuff out. And then lastly, the large intestine. And we'll stop, and I'll come right back to you because I have a puppy that needs So I'm going to have to pause for a second. Hold on, Mr. Puppy.